Welcome to Pomodoro Joe for Monday, April 17th, 2023. Today we're doing LeetCode problem 1431, kids with the greatest number of candies. This is an easy problem. All right, so there are n kids with candies. You are given an integer array, candies, where each candies index I represents the number of candies the ith kid has, and an integer, extra candies, denoting the number of extra candies that you have. Return a Boolean array result of length n, where the result at index I is true if, after giving the ith kid all the extra candy, they have the greatest number of candies among all the kids, or false otherwise. Note that multiple kids can have the greatest number of candies. Okay, so this is worded kind of weird, but basically we're just trying to see which kid has the greatest number of candies after you give potentially each one of those kids all the extra candies. So you basically give all the extra candies to kid 0, then see if they have the most candy. Then you take all those extra candies back and you give all those extra candies to kid 1 and see if they have the most candies. And you keep doing that for all the kids. All right, so with this, we'll put 25 minutes on the Pomodoro timer and get started. So let's see, our result is going to be a Boolean array of length n. Okay, so basically we'll have some result here. That's going to be an array, and we'll just set it to false to start with. And we'll multiply that by the number of kids. That's going to be the length of candies. So this gives us our result filled with false to start with. Now we're going to go through, do all these checks after giving each kid some extra candy, and we might flip these to true if we need to. And then at the very end, we will return our result. Okay, so now we're going to go through and give all these kids our extra candy. So let's see, for kid and extra candy, now I'll call it candy count. And we need to enumerate, because we're going to get the kids index and the candy count from their candies array here. So enumerate candies. Okay, so now the kid will have this candy count plus the extra candies. So let's check that. If the candy count plus the extra candy if that's greater than or equal to the max, we'll flip this to true. Well, what's the max candies? Well, we don't have that yet, so let's get that up here. The max candies, well, that's just going to be the max of all the candies. So basically this max will take this array and find the maximum value in that array, and that's going to be stored in max candies. So if we take our current candy count, add this extra candy, and it's greater than or equal to the max candies, then hey, we've got the max candy. So this kid will be true. So our result for this kid equals true. All right, I think that should do it. Let's check it out. And it's passing, so let's just see how well we do. And we do all right. We pass and we beat 87% for runtime and 50% for memory. So that's not bad at all. And it's pretty basic. We have some initial result array. We say it's going to be false to start with, and we'll just have false for every kid. So that's going to be the length of these candies. Then we need to find the maximum count so far. So that's going to be just the max of our candies. And then we'll just go through each kid and check their count. So enumerate will return the index and the value at that index of this candies array. So we have a kid and our candy count. So we'll add our extra candies for that kid's candy count, check to see if we have greater than or equal to the max candies. And if we do, then this kid is true. Pretty straightforward, and 87% is not bad. Let's see, we've got plenty of time on the timer, so let's see if we can get a better runtime. Yeah, let's just see if we can speed this up. Now, we can definitely speed this up by, what can we do? Ah, man. I kind of like this. I kind of don't want to change it. All right, we'll do the simple thing just to see. We're gonna rename all of our variables, make them really ugly, but it should reduce our parsing time. So let's see. Result becomes R. Let's see, Candies, we'll leave that. We'll call this MC for Max Candy. We'll call this K for Kid and C for Candy. All right, so now this is particularly unreadable, but it might actually reduce our runtime. So let's just see. Still works. Let's see if we can. I just kind of want to get over 90%. Oh, that actually makes it worse. What? Okay, so that didn't help us at all. Okay, what else could we do? We could do our own max calculation here, maybe. I don't think we can do better than this max, but let's give it a try. All right, let's give it a try. So we're gonna set our max candies to start with at 0, and then we'll say for candy in Candies. All right, so we're kind of doing our own max here. So we're going for every candy in our candies array. Our max candies will be equal to the max candies only if the max candies is already greater than candy. Otherwise, it's going to be equal to candy. Okay, so I don't think this is really going to make any difference. It's probably going to be slower, in fact. But hey, it's worth a shot. No way! I can't believe this. So this gets us to a 98.48% runtime and a 50% in memory. Oh man, I am shocked by this. All right, so by writing our own max equation or max algorithm here, we do way better. We beat 98% for runtime and 50% for memory. That's a win. I can't do any better than that. Let's see if you can. Give this one a shot. Again, this is LeetCode problem 1431. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you can go out and write better code.